Hello friends, welcome back to my channel. Today I am going to introduce you a new software. Not new, it is old one, a PSpice student version software. In that software we can draw any diagram from electronics and we can see the output or result of it in terms of voltages or currents, or we can see the result in terms of graphs as well. So you can see here, this is a PSpice schematic student software. You can download it anywhere from Google. It is of only size of 27 MB. So you can see here, uh, this is a PSpice schematic where this is a title bar. It shows the PSpice schematic and the schematic dot one. So this is the page one. So this is the page one actually. Now you can see these are some menu bars. So you can see here, this is the file menu: edit, draw, navigate, view, option, analysis, tools, markers, windows, and help. So you can use these menus to get working of the particular software. You can see in a file menu, you will see it's same like the other software, new, where you can create a new project. Open, you can open the previous project. Close, you can close the existing project. You can export the project. Save, you can save as in a different location. Print setup, and all these things are there. You can see I have made some recent projects in here, so that recent projects is indicated over here. So if I want to close it, I can click here to close it. So I am going to take a new project, then I am going to save according to my need. So edit, where it is same like the others: undo, redo, cut, copy, paste, delete, select all, and all these things are here. Where we are going to use rotate, flip, these are the two particular things that we are going to use when we are using this particular software. So kept in mind, rotate, for the shortcut for rotate is Control R, and for flip it is Control F. When we are using electronic component, if we want to rotate that component, we are going to use Control R, and if you have to flip it, we are going to use Control F. Then in draw, we need again the part called as a place part, where we are going to use a shortcut called Control P. For wire, we are going to use a shortcut called Control W, and for bus, we are going to use shortcut as a Control B. So this is from the draw. Here is again the next thing, important thing, that is get new part, Control G, where we can take the new, can say, the component of electronics from that get new part. We can close in here. So this is the control get new part. And rewire, if you have to make the connection again, we can use Control D shortcut, rewire the connection. Then there is a navigate, where we have only one page in here. We can have different pages and we can go to the next page and so on. So this is the navigate option for it. Then there is a view. We have to see the entire screen as like fit in, out, or area. So we can view that page in here, or we can view here entire page at once. So you can see, if I click entire page, this will look like. If I on fit, if I click on in, it will be zoom in and zoom out. So we can see when we draw the diagram of it. So then there is a next called as option, where we can see the display options, how to display it, how many grid the grid will be there, what will be the size of that grid, and so on. Then you can go for page size. What will be the page size? Is to be A4 or A, B, A3, A2, A1, and so on. So we can select from here. Then there are other options called pan and zoom and so on. Then there is analysis. This is very important, where we are going to use electrical rule check. So this electrical rule check is very much important when we are checking the errors, or if there are some warnings, and that's all. Then there is a setup option. Setup option is important, where in which setup we have to run the particular socket. Can take this from this analysis setup option. So you can see here, there are so many setups are available. We are going to see one by one. Then there is a next part called as simulate. So F11 is shortcut for that. If we simulate it, so it will show us the simulation in a simulation. So there are tools, where we have a If we go for the PCB designing, then we need a create layout netlist, then we have to run layout editor and so on. So for that purpose there is an tools. So we are going to stick towards the just first for the simulation purpose only. Next upcoming videos we are going to take towards the PCB designing. These are the markers where we can mark the voltage levels and current level in here. We can clear all or show all, or we can have a show selected option. Windows, where we can see how to take the windows like cascade format, horizontal tile, vertical tile, and so on. The help, can take the help of for this using the web resources or using this help topics. This is the about PSpice schematic. You can see here. This is the 9.1. Uh, we need a web update of it, or you want to download the PSpice software, you can go to the cadence.com website. So let's start. This is something available in here that is called as a toolbar. You can see here. We can take the new page in here. If we can open from here, if we want to open some sort of previous project, we can save in here. Then can have this shortcut keys here, zoom in, zoom out, and so on. Fit to page. Here is a wire options. You can draw wire. Here is an option called as draw bus. Here is a draw block. Control Control G, get new part. You can take in from here. The library, which component I have taken in here, that will be shown in here. Then if we want to simulate or setup, we can click on here. It will go to the simulate window. This is the shortcut, and if we click on this, it will be simulated. Then this is voltage marker, current marker, voltage levels and current level. So you can display the voltage and current over here. This is again the extra toolbar is available in here. So this is title bar, menu bar, toolbar, and this is the editor window. So where you can edit. So here all available that you can edit in here. The editor window for this particular. So let's start. Suppose I want to test the Ohm's law. So what we can do to test the Ohm's law? I'm going to go to the draw, get new part, or we can take that get new part from this place. So I'm going to click over here. What I need, we need VDC. So I'm taking VDC. Just clicking on the plus, so I can place over here. Okay. Then what we need, suppose resistance are going to place again over here. Then I need another one resistor, can place over here, click over here. I am done with, I don't require any other things, or in suppose if I require the ground, so that the will be completed. So ground earth I'm going to place in here. I am done with this, so I have to close it. So I'm going to close it. Now it is stick with my pointer, so I have to press escape, so it will be gone. Then I have to fit to page. Okay, so it will be fitted over here. Now you can see here, this is a resistance I can draw here. This is the VDC supply. Another one resistor. This is actually the ground terminal. So I am going to click over here, fit to page. So this is VDC. What we need now, we need to connect them together. So for that purpose, what we need a wire connection. So for that we need a placing of it. This resistance is like horizontal direction. You can see this resistance is also horizontal. So what I need to go into a draw, C, or we can go in edit to rotate or flip the particular component. Control R is for the this resistor to rotate it. So I am going to click over it, so it becomes a red. Then I will press Control R, will be in a vertical direction. Going to drag over the places where we required. Control R. So what we need, the ground to be placed some more here. Going to zoom to fit page, so it is fit to the page. Now what I need to connect them together. So I am going to draw wire. Control W is the shortcut key for that. So there will be like pencil thing. I'm going to connect. So I have to click on the one part, then I am going to click on the other part. Just let me on what we can call the text. So next, Control W. I am going to click over here, connect it to the ground. Click over here, connect to this resistor. Click over here. You can see here I am done with the connections. I need VDC, resistance R1, resistance R2, and a ground terminal. You can see here this is a ground terminal where there is a node. That node actually due to 1, 2, and 3. So there are 3 wire, they are coming together, form a junction. That's why it is called as a node. So you cannot see here there is no kind of node because they are just a wire. Okay, so they are connected from one point to other point. So there are 2 or more junctions, so we can say this is a node. Okay, so let me erase. So you can see here if I click over here, will fit to page. Now I need to give some voltage, so I'm going to click on it. So this is the DC. I'm going to give voltage called as 5 volt. Save attribute. Okay, so this is a 5 volt supply. Now this is 5 volt supply. This is R1 resistance 1 kilo ohm, R2 resistance 1 kilo ohm. So if I want to just check what is the errors or warning in there, I'm going to electrical rule check. The new schematic must be set, so I'm going to click OK. So create a new folder, voltage, or we can say test ohm law, Ohm's law. We'll click, save it, then analysis electrical rules. Here that you can see here this is the message viewer, or you can go in here, view messages. So the messages those will be like blink. You can see here this is the message window where you can see here the netlist is completed. One message is there. Okay, 0 error, 0 warning. Okay, there is only a one info. So we are done with the electrical rule check. There is no problem at all. So now we are going for analysis setup. Okay, we are going for bias point detail, close, analysis, simulate. After the simulation we'll get a simulation window, but we don't have any kind of graph that we want to draw. The simulation window, you can see here the simulation window is actually a blank window. We don't need simulation graph for this particular socket. What we require what are the voltages available in it. You can see here the voltage available in at this point V1 is equal to 5 volt. You can see here this is resistance R1 and this is resistance R2. They both are actually of a value 1 kilo. So that's why you can see here this is nothing but a voltage divider rule actually, where you can see that voltage divider rule tells us that if this resistance R1 and this resistance are having the same value, then the voltage will be divided by 2. That is called as a 0.5 volt. So as you know, the voltage divider rule is like same. We have to measure the voltage between this A point, ground point. So we can say that voltage across R2 should be calculated as VR2. That is given by what is the value R2 divided by R2 plus R1 to V1. Here is a V1. So you can see here. So what is R2? This is 1 kilo ohm, and what is R2 plus R1? This is kilo ohm into 5 volt. You can see here kilo ohm get cancelled. 1 half of 5 is 2.5. So you can see here the voltage at this terminal is 2.5 volt. So from this particular thing you can see that the voltage that is flowing through the circuit and voltage is available in between these two resistors is 2.5 volt. Now if we want to explain the Ohm's law in here, what we need to do, we need to understand what is the voltage drop across VR1, what is the voltage drop across R2, and so on. So if we get a voltage, we know the resistances, then we can calculate a current over here. So in this circuit, you can, if we click on current I, let me pointer here, you can see here this is the current. So let me erase. So you can see here the resistance over here is 1 kilo ohm, the voltage is 5 volt, and the current flowing through this circuit is 2.5 milliampere. So how it is to be calculated? So you can see here voltage is 5 volt, total resistance in the circuit, that total R, you can say RT, equal to R1 plus R2. So that is equal to actually 2 kilo ohm RT. From that, V is equal to I R. So V is equal to 5 volt, R is equal to 2 kilo ohm. So if we calculate the values of it, we can have what will be the value of current upon R. So V is 5 upon 2 kilo ohm, that is equal to 2.5 milli. You can see here, you can see directly the current that is flowing through this circuit is of 2.5 milli. So in this way you can use this PSpice software, calculate the values of the current any branch. Let's see here, here is only one loop available. That loop is started from V1 plus, it will go towards the resistance 1, resistance 2, ground, and towards the negative part. This is only a one loop, that's why we are getting a current called 0.5 milliamp. So if we suppose we have different loops, then we can calculate the current as well. So let me just show you. So what we can do, we can take the resistance R over here, the resistance I put over here. If I rotate it, if I place over here, then control W, the wire will be there. I will use to connect in here. So now I'm going to check electrical rule. Setup is same, bias point detail. By going to click on simulate. So simulation window, we don't have anything on simulation window. So I'm going to click on V on R. You can see here the current that is flowing from this particular part, means this particular branch is of 2.5, because resistance 1 it becomes a 2 kilo ohm. The current is, you can see here from Ohm's law, the current is 2.5 milliampere. We have calculated it. Now there is a second branch where the voltage drop across it, this resistance R3 is actually 5 volt, because of, if just neglect this branch, so current that will flow in this circuit, so it will be nothing but that is will be flow in 1 kilo. But now there are two branches, so the current that is flowing to this, from this branch and from this branch, according to Kirchhoff's current law, KRL or KRL, you can see here the current entering to the node equal to current leaving the node. So you can see here the total current will be required 7.5 milliampere. So 2.5 will be flow in this particular branch, and the other 5 that will be flow branch. So you can see here why this is a 5 milliampere, why not 7.5 milliampere, or why not 2.5 milliampere, because the voltage drop is 5 volt and the resistance is 1 kilo ohm. So that's why the current that is flowing this branch, you can say, that will be according to Ohm's law, that will be equal to 5 milliamp. And according to this, the Ohm's law, 1k 1k, there are resistance, they are 2k, voltage is actually 5 volt, that's why the current is 2.5 milliamp. That's why we required a 7.5 milliampere of current, so that our condition of the KCL will be fulfilled. So this is the way we can calculate the Ohm's law can prove the KCL, can prove the KVL, and so on. So this is the way we can use this software to simulate any kind of electronic circuit using